Take it away.
Hopefully I can get you in here. Uh, okay, do you see that?
Nope.
Can't see anything. Well,
No, you got to start the slideshow in PowerPoint, and then go back to the then you need to go back to the Zoom screen.
go back to
So is the slideshow going?
uh, yeah.
Okay. Now go back to the Zoom session.
I gotta share it though, don't I?
Yeah.
Okay, wait a minute. Let me.
So then at the bottom of the screen, bottom of the Zoom screen, you should be able to share it and then pick the slideshow.
Uh, okay.
There you go.
Oh, well, that's not quite the right one.
We're seeing your whole screen, Marv. Like it says chapter 9, part 1, but it shows all the other images on the left.
Yeah, I'm going to. Okay. So what do you see?
Okay. All right. Now,
Oh.
Marv, stop sharing. Go in the Zoom screen and stop sharing.
Stop sharing. Okay.
Yeah. And then start sharing again. Nope.
Gotta find out how I stop sharing here.
On the Zoom screen, there's a thing at the bottom, or maybe it's at the top. Okay, there you go. Now click on share again, but this time select the slideshow that just shows the one slide.
Share.
Yep. And then you should see, you should see several choices, and one of them will be the slideshow.
Well, that's what I selected.
Hmm.
I think what's happening is he's selecting the slideshow on his computer and not on the Zoom screen. You need to select the slideshow on your Zoom, the black Zoom screen, not on your computer. Uh, uh, Zoom on mine comes up as black.
See that now?
Yeah.
That's right. That's
good.
correct.
Yeah.
That's
There
the
you
right
go.
way.
So we're good now.
Yep.
Good. We're good.
All right. Okay. So when you're setting up your shack, it's incumbent upon you to make sure that you establish uh, safety, safety procedures so that you prevent electric shock, and not only that you prevent electric shock, but that if something does happen, that people can shut down your system. Uh, Most of us, I think, depend on our main circuit box to do that. Though it would be probably best if you could you could set up a separate box at your shack and set up your outlets and whatnot to that. You should have a master off and on switch uh, for the station and a workbench, and have everything clearly labeled. And obviously don't put yourself in a position where you can be shocked. Of course, modern radios are not like the old tube types where you had a lot more voltage and whatnot. However, if you're using a tube type amplifier, you could have a real problem because they generate massive voltage. And you really have to be careful with those. So if you're, if you're experimenting and working inside your equipment, you've got to make sure that everything is insulated and you secure all your wires and cables. Yeah, so to limit the possibility of shock. And you should use a grounding stick to remove chargers from capacitors. That's people don't often realize that the capacitors hold a charge for quite a while. Here's you do have in your book a picture of a grounding stick. Another way to do this is just to take a wooden dowel, maybe a 3/4 inch or 1 inch wooden dowel, and a couple of feet long, and put a eye bolt in the end of it, and with a stranded wire and a alligator clip. That's pretty easy to do. Here's a chart of voltages and currents. It's a current that does it, and you're up to up to 5 megaamps. There isn't too much trouble, but after that, you're really it's going to be painful and possibly deadly. So it's something you got to really be careful of. I don't know why I've got that yellow. Are you seeing a yellow line? Like a yellow rectangle?
At the top of the screen, there's a blue and yellow line, but it's not centered. The slide isn't centered in the zoom thing here. Part of it's cut off on the screen. There's no yellow on my thing.
Yeah.
Yeah.
Yeah, on mine, everything is cut off on the left.
What's that?
Correct.
Hey, Mark, try hitting Control minus. That might. I don't know if that'll work to shrink it or not. Maybe not.
Control minus.
Yeah.
Maybe it'll work for websites. I don't know
Just
if
do
it'll
it
work.
once to see what happens.
Oh shoot! Sorry, guys, I messed up.
You tried.
Well, I mean, we can see it all now.
Yeah.
Now I know it's soldering and not just ring safety.
Yeah, we're seeing ring safety.
What are you seeing up there? Are you seeing like a green rectangle?
No,
Okay. All right. But you're seeing soldering safety.
no, we're seeing ring safety. It's cutting the SOLD off.
You're seeing what?
It's cutting off half the screen. Kim, describe it better. We're only seeing the word ring safety. I'm sorry. RING in the word safety.
Oh, okay. Now let's see what I could do about that.
It's cutting off the left
Let me
image.
go out of this and go back into it. Just a minute.
And by the way, DC voltage shocks you differently than AC voltage. When you get shocked with DC voltage, your muscles contract and you can't let go of the wire. With AC voltage, your hand naturally lets go of it. So when you work with DC power, you have to be extra careful because it contracts the muscles.
Let me get out of how do I get out of sharing? I want to stop sharing. I want to shut this down and bring it back up again. Just a minute. All right. Just a minute. Let me.
Or would you like me to walk you through it again? Oh, there you go. Nope. Nope. We're back to ring safety.
I don't know what is happening. Why I'm getting that.
I don't either, but um, bear with me, Marv,
Try something
and
different.
use Alt Tab to go to the Zoom screen if you're not looking at it already.
What's that?
Are you looking at the Zoom screen that's got people going across the top? Oh, okay. All right. Okay, Marv, what I want you to do is go into PowerPoint and start the slideshow. Don't do anything else. Just start the slideshow from the point you want it to be.
Just start the slideshow.
Yeah, start the slideshow. It's gonna cover the Zoom screen, but we'll get right back to it.
Well, I can't start the slideshow without well, just a minute. Maybe I can.
Yes, yes, you can. From PowerPoint, start the slideshow from the slide you want.
Well, I'm already starting. I'm already in the slideshow.
Okay, now use Alt Tab on the keyboard until you select the Zoom screen.
All right, just a minute.
You should be able to get the Zoom screen back on top.
Wait a minute, let me do this. So what do you want me to do now?
Okay, are you looking at the Zoom screen?
The Zoom screen.
Yeah. Yeah, you need to use Alt Tab until you can see the Zoom screen with everybody's image on it.
Uh, the Zoom screen.
Yeah.
Uh, okay. What about it?
Okay. So now click on share, but don't do anything else yet.
No, that doesn't work. Wait a minute. Oh, wait a minute.
Nope. I'm sure what's going on. Try. Oh,
I'm still getting that thing cut
yeah,
off.
it's still getting clipped.
I didn't
On
have,
my version, it could be one of two things. To you up in the right-hand corner next to the X, there's a square. To click on that and see if it's a matter of it's not on one full screen. And then the
He's
other thing,
clicking on, he's not on the Zoom screen. He's clicking on his computer.
right,
He
but I
needs
mean
to be,
on the PowerPoint. The other thing it could be is it could be a display settings thing on PowerPoint
Hmm.
where the settings are such that it's not squishing it down to whatever screen you're on. I was just bringing up an old PowerPoint of mine to see if I could figure out what was going on. Yeah, okay. Bring bring up the PowerPoint that you had before. The one that had,
PowerPoint I had before.
well, the one that had all the slides to the left and everything.
Oh, okay.
Just bring that one up for a second.
Well, in order to do that, I got to get out of this.
Yeah, I think I know what it is. Maybe I can demonstrate it if I can. Okay. Oh,
hey,
there
you
you go.
got it.
You got
It's
it.
working. Don't do
Okay.
anything.
Yeah, we're good.
All right, let's go back here. All right. All right. So, all right, we're on soldering safety. Solder is primarily lead-based. with tin added for a lower melting point. But lead is a known toxin, so solder should be used in a well-ventilated area. And rosin flux smoke isn't very good for you, so you gotta watch that you don't expose yourself too much to it, unless you're in a well-ventilated area. If you're using solder, make sure you wash your hands carefully after you've been using it, so that you don't contaminate food or something else, or bring it to your mouth or whatnot. Beginning in 2006, they've gone to solder that is more lead free. But it has its problems too, because it's got a higher melt temperature, so it risks damaging heat sensitive components. So it's a trade-off, but it's safer to use. Practice questions. You've probably forgotten everything we looked at. Which of the following is a danger from lead tin solder? Lead can contaminate food if hands are not washed carefully. High voltages can cause lead tin solder to disintegrate suddenly. Tin in the solder can cold flow, causing shorts in the circuit. RF energy can convert the lead into a poisonous gas.
A.
A.
Yeah, I agree.
Yeah, A. Wiring practices. Oh. In a National Electric Code Handbook contains details for handling AC wiring in the home and your station. And I don't know if you necessarily have to have a handbook, but certainly you can get information on local building codes to ensure that your home is properly wired to meet local conditions. But there are standard wiring conventions. You know, your hot leads, red or black, could connect to the brass terminals. Your neutral, which is the white insulation, goes to the silver terminal or screw. And your ground, which would have the green insulation, or it's a bare wire, goes to the green or bare terminal or screw. But those are universal. And it goes without saying, don't run antenna feed lines over power lines or service drops from a transformer to the house. Here's some typical wiring conventions for receptacles for 120 volt and 240 volt AC plugs that you might find. House AC wiring, most common sizes are number 12 AWG for 20 amp circuits and number 14 for 15 amp circuits. So you should use a fuse or a circuit breaker in the hot conductor for 120 volt circuits, or both hot conductors of a 240 volt circuit using 3 or 4 wires. So here's a table typical current carrying capacities of some common wire sizes. Again, the 12, the rating of wire to carry current is called ampacity. So allowable ampacity for copper wire 12 AWG is 25. And so the maximum fuse or circuit breaker would be 20 amps, and 14 would be 15 amps. And those are typically what you might be using in your home. Use a circuit tester to make sure that everything is properly wired. I myself, I might fool around. I mean, not fool around. I might, if I need to do something, add an outlet or something like that. I've done that sort of thing, but I never do anything at the main box. I leave that for an electrician. That's beyond my pay grade. Fuses and circuit breakers. Fuses do so by melting a short strip of metal. And circuit breakers act like fuses and trip when current overloads occur. Make sure that you're using properly sized fuses and circuit breakers. Don't shortcut this. It's not a smart thing to do. Make sure that you're installing the fuses and circuit breakers in the correct lines. Never put them in the neutral or ground line. Make sure that there's a fuse or circuit breaker on the hot conductor for 120 volt circuits, or both hot conductors on a 240 volt circuit. It's a picture of a ground fault circuit interrupter. You probably have these in your kitchens, in your bathrooms. These are quite common now. They're used in AC power circuits to prevent shock hazards. They trip if there's an imbalance. If it senses an imbalance in the currents carried by the hot and neutral conductors. They're very sensitive, as you probably have experienced at one time or another. It's quite common to see safety interlocks on cabinets or enclosures when there's very high voltages. If you ever get an amplifier, especially a tube type amplifier, you're going to find a safety interlock almost for certain. There are several types. There's physically disconnects high voltage or RF when activated, and shorts or grounds high voltage circuits when activated, possibly blowing a circuit breaker or fuse in a power supply. Practice questions. Which wire in a 4-conductor 240 volt AC circuit should be attached to fuses or circuit breakers? Only the hot wires, only the neutral wire, only the ground wire, all wires.
A, only the hot wires.
Wires.
Yep. A. Mhm.
According to the National Electric Code, what is the minimum wire size that may be used safely for wiring with a 20 amp circuit breaker?
C, 12 volt. I'm sorry, 12 gauge. AWG.
Yeah, C. Which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14 wiring? 30,
D,
25.
D, 15 amps. This is all I did for a living. I know this like the back of my hand.
Right. Which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power? Current flowing from one or more of the hot wires to the neutral wire, current flowing from one or more of the hot wires directly to ground, over voltage on the hot wire. All these choices are correct.
All the choices are correct.
Hmm?
I think all the choices are correct.
Hmm.
B.
If I'm wrong, see how I got electrocuted.
Current flowing from one or more of the hot wires directly to ground. Which of the following is covered by the National Electric Code? Acceptable bandwidth limits, acceptable modulation limits, electrical safety of the station, RF exposure limits of the human body.
C,
B. What is the purpose of a power supply interlock? To prevent unauthorized changes to the circuit that would avoid the manufacturer's warranty, to shut down the unit if it becomes too hot, to ensure that dangerous voltages are removed if the cabinet is opened, to shut off the power supply if too much voltage is produced.
C.
Yep. C, to ensure that dangerous voltages are removed if the cabinet is opened. Generator safety.
Get this one.
Fueling and ventilation problems cause more injuries associated with generators than from any other cause. Yeah, you got to be careful with generators. You should install your generators outdoors because carbon monoxide in exhaust can quickly build up to toxic levels. So don't put it in your garage. Don't put it in your basement. When using generators regularly, install CO detector alarms in living and working areas. When I was years ago, uh, I lived out in Rochester Hills in a subdivision, and there was a woman. She was having mental issues, depressed, and she decided that she wanted to commit suicide. She was married, had a family, kids, and she got up in the middle of the night and went into the garage and sat in the car, closed garage, sat in the garage, and started the engine and filled the garage with carbon monoxide, and she killed herself. But the problem was the bedrooms were up above the garage, so she took out her whole family.
The other thing about generators is you want to make sure that the exhaust is pointed away from the house. A neighbor 2 streets over put his generator, because it was raining, right up against the house, and the exhaust was pointed towards the plastic siding, and the plastic siding caught on fire and burned his house down. So make sure when you do an outdoor generator to keep it at least a foot or two away from your house, and make sure that the exhaust is pointed away from the house. It's also a fire hazard when you have the exhaust pointed right at your siding.
Yeah, that's a good idea. Generators should always be shut off when refueling to avoid igniting fumes or splash liquid from the spark plug. The fire extinguisher should be kept near the generator and separated from the fuel. Which of the following is true of an emergency generator installation? The generator should be operated in a well-ventilated area. The generator must be insulated from the ground. Fuel should be stored near the generator for rapid refueling in case of an emergency. All these choices are correct.
No, no.
I'm going to say A.
Hey, yeah.
Okay. Okay, lightning. Well, the goals of lightning protection is to provide fire protection for your home and obviously to reduce and prevent electrical damage to your equipment. And this happens quite often. People lose all their equipment to so you should use a metal entry panel where signal and control cables come into the house, and the panel should be grounded with a short metal strap, as short as possible. So you should have a ground rod right close to that metal entry panel, and bonded to it, and then that should also be connected to your to the ground rod that supplies your AC into the house also. You should have lightning arresters installed at the entry panel. Again, grounding wires and shafts should be as short as direct as possible. Don't use solder to make ground connections. You can use mechanical clamps, you can braze it or weld it. All towers, masts, and antennas should be grounded. Why should solder joints not be used in lightning protection ground connections? Solder joint will likely be destroyed by the heat of a lightning strike. Solder flux will prevent a low conductivity connection. Solder has too high a dielectric constant to provide adequate lightning protection. All these choices are correct.
A,
Yeah, hey. Where should the station's lightning protection ground system be located? As close to the station equipment as possible, outside the building, next to the closest power pole, parallel to the water supply line.
I'm muted. Sorry. I would say B as in boy.
Yeah, outside the building. Which of the following is required for lightning protection ground rods? They must be bonded to all buried water and gas lines. Bends in ground wires must be made as close as possible to a right angle. Lightning grounds must be connected to all ungrounded wiring. They must be bonded together with all other grounds.
D.
Yep.
Yeah,
And it's interesting because I don't think the guy who put up my TV tower a few years ago actually did that.
Yeah, D, they got to be grounded together, bonded together with all other grounds.
Yeah. Hmm.
Where should lightning arresters be located? Where the feed lines enter the building, on the antenna opposite the feed point, in series with each ground lead, at the closest power pole ground electrode.
Where the feed lines enter the building.
Mhm.
Yep. A. Yeah, A. RF exposure. Now, at high power level, for some frequencies, the amount of energy that the body absorbs could be a problem. Maximal permissible exposure, MPE, is the maximum intensity of the RF radiation to which a human being may be exposed. The factors to be considered when estimating the MPE would be the transmitted power level or density, frequency, average exposure time, and duty cycle of the transmission. The power density and frequency are the primary ones. Wrong way. Now, stations with a time average transmission of more than 1 milliwatt are subject to the FCC's RF exposure rules. If your station exceeds the exemption criteria, you will need to evaluate it according to the FCC OET Bulletin 65. Power density. Heating from exposure to RF signals is caused by the body tissue absorbing RF energy. This is not as big a deal as they're making it out to be here, but or it doesn't have to be. It's measured in milliwatts per square meter, centimeter, I'm sorry. Could also be RF field strengths could also be measured in volts per meter or amps per meter. But milliwatts per square centimeter is the most useful for amateur requirements. It's highest near antennas and in the directions in which antennas have the most gain. So decreasing the transmitter power, increasing distance from the antenna lowers power density and lowers RF energy, and vice versa, obviously. So looking at absorption and limits, the specific absorption rate, which is the rate at which energy is absorbed from the power to which the body is exposed, is the best measure of RF exposure, but it's difficult to measure because it varies with frequency, power density, the average amount of exposure, and duty cycle of transmission. So it depends on the frequency and size of the body or body part affected, and it's highest where the body and body parts are naturally resonant. So the safe levels of specific absorption rate is based on demonstrated hazards have been established by the FCC in the form of maximum permissible exposure, MPE levels. the MPE limits vary with frequency because the body responds differently to energy at different frequencies. The controlled and uncontrolled limits refer to the environment in which people are exposed to the RF energy. Now, what's controlled and uncontrolled? We'll get to that. So let's take a look at 9.3. So limits for occupational controlled exposure. You guys can look at this in your book, and it's really easy to figure out. We're going to get to a formula for figuring it out. Because you've got limits for the radio operator, and then you also have limits for the general population, which is the uncontrolled exposure. But you have so many variables. It's difficult to call it. So exposure to RF energy is averaged over fixed time intervals. And time averaging evaluates total RF exposure over fixed time intervals also. So you've got two types of averaging periods: controlled and uncontrolled. The controlled is us, the operator, the licensed operator, and the uncontrolled is the guy on the street, your next door neighbor. Controlled is, again, you're aware of your exposure and expected to take reasonable steps to minimize. And, oh, wait a minute. Keep going the wrong way here. In the uncontrolled environments, the general public has the access. If people in uncontrolled environments are not aware of their exposure, but are much less likely to receive a continuous exposure. But so that would be your next door neighbor. If you're running field day, would be, and you're set up in a park, people walking through the park, what would be their exposure? The duty cycle is the ratio of the time the transmitter is on to the total time during the exposure. It's same as the duty factor, but duty factor is expressed as a fraction instead of 25%. 0.25 instead of 25%. So lower transmission duty cycle permits greater short-term exposure levels for a given average exposure. That's called the operational duty cycle. The less time the transmitter is on, the lower the average exposure. for reading greater short time exposure levels for a given average exposure. Now remember, now we're talking what's coming off the antenna, not what's coming off the transmitter. So if you're sitting in your shack and your transmitter is on, you're exposed, we're talking what's coming from the antenna, which is at some distance from your, one would assume, from your transmitter. Along with operational duty cycles, the different modes themselves have different emission duty cycles. So the modes have different duty cycles. So for example, a conversational single sideband has a duty cycle of 20%. Conversational CW has a duty cycle of 40%. Now, you notice that they have a conversational single sideband duty cycle 20% and conversational single sideband 40%. So, but you have to go down to the notes. The first one, the conversational single sideband, includes voice characteristic with no speech processing. And the second one is heavy speech processing. I do about I probably do maybe 2% of my operating is single sideband. Everything else is CW. 98% CW. But for most operators, listening and transmitting times are about the same. So operating duty cycle is rarely higher than 50%. We listen a lot, or we should be. Calculating average duty cycle power. So a station is using single sideband without speech processing, transmitting and listening for equal amounts of time and with transmitting power of 150 watts. Calculate the average power output. So transmitting power times emission duty cycle times operating duty cycle. Transmitting power is 150 watts. The emission duty cycle for conversational single sideband without speech processing is 20%. Operating duty cycle is 50%. So the average duty cycle power equals 150 watts times 20% times 50% equals 15 watts. Estimating exposure and station evaluation. So ERP is the effective radiated power. All fixed amateur stations must evaluate their capability to cause RF exposure, no matter whether they use high or low power. So limits vary with frequency and peak envelope power. You're required to perform this evaluation if your power exceeds the levels shown for any band. See that in table 9.5a. Table 9.5b gives the minimum distances from the antenna for which the FCC exemptions can be used for most amateur bands. Exposure evaluations is performed by 3 different methods: measuring RF field strength with calibrated meters and calibrated antennas, use computer modeling, calculations per FCC OET Bulletin 65, or the easiest way is just to use that online calculator. So let's try that. Let's see if we can get to that calculator here. Take me a minute to get it up. So can you see this?
Yes.
Okay. So let's say the power at the antenna. Let's say I'm running 200 watts. But I'm let's figure I'm about about 160 feet. The length of my transmission line is about 160 feet. So let's cut that down a little bit. So let's say it's there's a couple of things in there. So let's say it's 190 watts. And let's say I'm running conversational CW. And so I'm transmitting for 5 minutes and receiving for 10 minutes. And we're going to figure antenna gain. It's a dipole. I've got I'm running a Carolina Windom dipole. So figure a dBi of 2.15. And I do a lot of 30 meters. So let's say 30 meters. Oh, I got to operate just a second here. 10.115. Calculate. So the minimum compliance distance is a little over 1.5 feet in feet for the controlled environment. For someone just wandering in my backyard, the minimum compliance distance would be a little over 2 feet. So I'm good. Very unlikely with that antenna at 40 feet that I'm going to have any problem cooking anybody's brain. Let's try it. Let's try it with 40 meters. Let's say 7.040. So again, uh, for the uncontrolled person, that my next door neighbor happening to wander into my backyard, the minimum distance is about a 1.5 feet. And so again, not a problem. So it's really not that big a deal, but we need to do this. And you're supposed to put together a little package. You know, you could print the results, and you could put together a little package so that if for some reason or other the FCC knocks on your door, you could show them this.
Okay, Marv, it's 8:15, so why don't we take a little break?
Okay. Okay, we ready?
Ready.
I think maybe Kim. I think Kim maybe left us.
I'm here. I just had my video off.
Oh, okay. So what do you need to calculate RF exposure? Power at the antenna includes adjustments for duty cycle and feed loss. You need the antenna type, you need the antenna height above ground, you need the operating frequency. So minimum, so you got minimum exemption distances. So again, looking at uh, uh, 40 meters over here, 22 feet. $20 meters, 11 feet. These are all quite doable without any problems. Again, remember, these are from the antenna. So your antenna is up in the air. $80 meters, 43.5 feet. So what are good practices for safety measures? Choose, locate or move the antennas away from where people can be exposed to excessive RF. Locate the antennas away from property lines and place fences around bases of ground-mounted antennas, like a vertical. And don't point gain antennas where people are likely to be. Use beam antennas to direct RF energy away from people. If you're using a stealth or attic antenna, make sure the MPE limits are not exceeded in living quarters. And VHF and UHF place the mobile antennas on roof or a trunk of the car to maximize shielding of the passengers. And use the dummy load or dummy antennas when testing a transmitter. And reduce the power and duty cycle of your transmissions. You should be using no more power than you need to make your contact. What is one way that RF energy can affect human body tissue? It heats body tissue, it causes radiation poisoning, it causes the blood count to reach a dangerously low level, it cools body tissue.
A,
Yeah, heats body tissue. Just like your microwave.
Hmm.
Which of the following is used to determine RF exposure from a transmitted signal? Its duty cycle, its frequency, its power density. All these choices are correct.
All are correct.
All are correct.
All of them are correct. How can you determine that your station complies with FCC RF exposure regulations? By calculation based on FCC OET Bulletin 65, by calculation based on computer modeling, by measurement of field strength using calibrated equipment. All these choices are correct.
Sounds like D.
Yep, D. All of them are right. What does time averaging mean when evaluating RF radiation exposure? The average amount of power developed by the transmitter over a specific 24-hour period. The average time it takes RF radiation to have any long-term effect on the body. The total time of the exposure. The total RF exposure averaged over a certain period.
D.
D, yeah.
Yeah.
Yep, D. Total RF exposure average over a certain period. What must you do if an evaluation of your station shows that the RF energy radiated by your station exceeds permissible limits for possible human absorption? Take action to prevent human exposure to the excessive RF fields. File an environmental impact statement with the FCC. Secure written permission from your neighbors to operate above the controlled MPE limits. All these choices are correct.
A,
Yeah.
A. You take action to prevent human exposure. What must you do if your station fails to meet the FCC RF exposure exemption criteria? Perform an RF exposure evaluation in accordance with FCC OET Bulletin 65. Contact the FCC for permission to transmit. Perform an RF exposure evaluation in accordance with World Meteorological Organization guidelines. Use an FCC approved bandpass filter.
A,
Yes, A. Perform an RF exposure evaluation in accordance with FCC OET Bulletin 65. What is the effective modulation duty cycle on RF exposure? A lower duty cycle permits greater power levels to be transmitted. A higher duty cycle permits greater power levels to be transmitted. Lower duty cycle transmitters are exempt from RF exposure evaluation requirements. High duty cycle transmitters are exempt from RF exposure requirements.
A,
Yes. The lower duty cycle permits greater power levels to be transmitted. Which of the following steps must an amateur operator take to ensure compliance with RF safety regulation? Post a copy of FCC Part 97.13 in the station. Notify neighbors within a 100-foot radius of the antenna of the existence of a station and power levels. Perform a routine RF exposure evaluation and prevent access to any identified high exposure areas. All these choices are correct.
D,
What?
D, Delta,
I'd say C.
Actually, C.
C, okay.
Perform a routine RF exposure evaluation, prevent access to any identified high exposure areas. You could be right if we took B out.
Oh, right.
What type of instrument could be used to accurately measure RF field strength? A receiver with digital signal processing, noise reduction, a calibrated field strength meter with a calibrated antenna, an SWR meter with a peak reading function, an oscilloscope with a high stability crystal marker generator.
B.
What?
I said B, a calibrated field strength meter with a calibrated antenna.
Yep. That's
Yeah.
it. What should be done if evaluation shows that a neighbor might experience more than an allowable limit of RF exposure from the main lobe of a directional antenna? Change to a non-polarized antenna with higher gain. Use an antenna with a higher front to back ratio. Take precautions to ensure that the antenna cannot be pointed in their direction when they are present. All these choices are correct.
C.
Yeah, see.
Yeah. That's what it says in the book too, but my instinct was how do you know if they're present?
What's that?
So that's what my book says too, but my instinct is,
Wow.
how do you know if your neighbor is present? You're gonna be a really nosy Gladys Kravitz.
Yeah, but it's really not that big a problem as you might think. As I was demonstrating there, running that formula from the ARRL.
It doesn't happen very often.
Well, if you've got a directional antenna, what kind of antenna is it going to be? It's going to be a beam antenna, okay? And how are you going to use a beam antenna? You're going to put it on a tower. So it's going to be up in the air someplace. So let's say you're at 50 feet. And it's going to be directional, but it should be going. It's unlikely to be directly. If somebody would have to be.
Like in a high rise.
It's just. You've got.
We get what you're saying. We get what you're saying. If you live in a house with beams 50 feet up and the guy's on the second floor story next to you and your beams are pointed at him in their apartment building, you're giving him RF radiation.
Yeah, I guess, but you're not likely to you're not likely to have it's unlikely that you're going to be in a situation where you've got a tower and have a apartment building right next to you.
I know. I just said for hypothetically.
Yeah.
That's what she's talking about.
Well,
I
okay.
think she gets, see, I think she gets it now.
Yeah, I do. So I didn't realize that you're likely going to have your antenna much higher than from the ground than your neighbors will be.
Yeah. But I could see, if somebody had a tall structure right next to you, or if for example, you lived on a hillside, or somebody lived on a hillside behind you, for example, yeah, it could be a problem under those circumstances. If you had a tower, yeah, you could be. Now I've got a friend who lives out in California, and he lives in one of the canyons, in a Los Angeles suburb, and he doesn't have a beam because he's got a neighbor that lives behind him up above him, and that neighbor would be looking right at his beam if he had a tower. His lot is tiny postage stamp.
Speaking of all this, I wonder how many people have checked their microwave in their kitchen, especially the ones above the stove. I checked mine and I don't stand in front of my microwave anymore a long time ago.
Oh, wow.
Yep, with a handheld meter.
What precautions should you take if you install an indoor transmitting antenna? Locate the antenna close to your operating position to minimize feed line radiation. Position the antenna along the edge of a wall to reduce parasitic radiation. Make sure the MPE limits are not exceeded in occupied areas. Make sure the antenna is properly shielded.
Sounds like C.
Yeah. Yeah. I'm getting behind here. What stations are subject to the FCC rules on hour of exposure? All commercial stations, amateur radio stations are exempt. Only stations with antenna lower than 1 wavelength above the ground. Only stations transmitting more than 500 watts PEP. All stations with a time average transmission of more than 1 milliwatt.
B. D.
D is correct. All stations with a time average transmission of more than 1 milliwatt. Okay, outdoor safety, installing antennas. So, as we've been talking, place all antennas and feed lines well clear of power lines. It's a biggie. No part of an antenna system should be closer than 10 feet from power lines. That answers your question from earlier, Ralph.
Yeah.
When working on roofs, trees, or towers, climbers and helpers should wear appropriate protective gear at all times. And you should have a safety checklist. To turn off and unplug all AC equipment. You lock out the circuits and tag them if possible. Transmitters should be turned off and disconnected from feed lines to avoid shocks or excessive RF exposure. You might wonder about some of these things, but sometimes you got to remember, if you get a few guys together, let's say, to help you put up an antenna, you could possibly have guys, somebody in your shack, and other guys out putting up antennas, and somebody could be screwing around and start to transmit, and there could be somebody holding on to the end of the dipole. It could be a shocking experience, to say the least. Belts and harnesses must be within their service life and adequately rated for weight.
Doesn't some cities, depending on towers and masts mounted on top of buildings, determine, even though you're so far away from a lot line or another house, if that tower is 20, 30, 40 feet tall, if it was to topple over, that particular tower could probably hit a house or a power line. Wouldn't that be how they would figure that?
Didn't I didn't follow you there.
Well, if you have a power line like in the back of your lot, between your lot and the behind you, and you have a 20, 30-foot tower or a mast on your house, if that particular mast fell over just as is, it would determine how far away from the lot line and the power line you'd have to be. When you're saying 10 feet away, it's not from where it's standing straight up and down, but how far, if that tower or mast fell down, how far would that extend out into the property?
Well, you got to use some common sense. I wouldn't put a tower 10 feet next to a power line.
Right. If it was to fall vertically down, down or horizontally rather.
That would preclude, it would be something you just wouldn't do.
Right.
There's a lot to talk about towers, but the long and the short of it is, if you anchor the tower and if you guy it according to the manufacturer's instructions, you should be good. Although sometimes it takes a lot of convincing for local zoning boards.
Right.
But the failure mode for most towers is to fall straight down or to break somewhere in the middle. And it turns out that the cause of most tower failures is improper installation. I think it was a fellow from Roan Towers who gave a talk at Dayton Hamvention several years ago, and he was saying basically that the notion that a tower would fall over from its base, like cutting a tree down, isn't something that happens very much.
Yep, that makes sense.
But it's kind of a complicated question.
But if you're thinking of putting up a tower, you should see if if the city or township that you're in has any tower regulations. They might. But like Wes says, if you follow the tower manufacturer's requirements for installation, you pretty much can't go wrong. They engineer those things pretty well. And don't take shortcuts. But you're also dealing not only with the tower, but also with the antenna, because the antenna has wind load requirements too. Which of these choices should be observed when climbing a tower using a safety harness? Always hold on to the tower with one hand. Confirm that the harness is rated for the weight of the climber and it is within its allowable service life. Ensure that all heavy tools are securely fastened to the harness. All these choices are correct.
And we all say D.
Say B.
Oh, B.
B. Confirm that the harness is rated for the weight of the climber and it is within his allowable service life.
The reason A is wrong is you're always supposed to have a 3-point contact when climbing a tower. If you either have 2 hands and 1 foot, or you have 2 feet and 1 hand.
Yeah.
I've climbed many a tower. They call that a 3-point. You have 4 ways of hanging onto that tower.
What should be done before climbing a tower that supports electrically powered devices? Notify the electric company that a person will be working on the tower. Make sure that all circuits that supply power to the tower are locked out and tagged. Unground the base of the tower. All these choices are correct.
B.
Yeah, B is obvious. Bravo.
Make sure all circuits that supply power to the tower are locked out and tagged. That's it. End of chapter 9.
All right. Real quick, I want to go over some safe electrical work safety practices. Say this is a disconnect or a power station, this box right here. When you approach it and you remove the main power to the master switch, like right here, or you're going to open it up, or you're going to open it, or the disconnect's on the right-hand side. When you walk up to it, all that electrical energy is right at your eyeballs, right at your eyeballs. So when you take your right hand and you pull that switch, or you take that and flick it here, if the switch is bad, it blows right into your eyes. So my career and my company taught me always stand to the left and use your left hand to shut off the power. And if there's a disconnect switch, you stand to the left and pull the disconnect switch with the left power. So when that blows open, it blows away from you. It doesn't blow into your face. So always remember to use your left hand when you shut off the power on any disconnect switch or master control. Then you take your meter and you make sure that you always test your leads. You put it on ohms and make sure that both your leads are working. And you better have a category 3 meter, because these cheap ones you get at Harbor Freight, if you put it on 240, will melt your leads or blow up in your face sometimes. So you want to get a category 3, it says right on it, which is rated for high voltage. Then the next step is you always test and verify. Once you make sure your leads are working and your meter's a category 3, you go to a known voltage source. And the way you know it's a known voltage source, you've seen these things where you plug it into the wall and it'll tell you that's a quick way to do it. The lights will tell you right here, you get in a safe work practice. So you go to a known voltage source and you make sure your meter's correct. So now that you've pulled the disconnect, you've locked and tagged out, you checked your meter leads, you check you got a category 3 meter, now you're ready to pull the fuses. I don't know if you can see this, but they sell them everywhere. This is rated for high voltage. So when you grab that fuse, you grab it in the middle and you pull it out like this. If you have a bladed fuse, hang on, I got one right here. If you have a bladed fuse, you see the blade on the bottom and the top, and you grab it at the bottom and you don't have it, what happens is the top might be energized. When you grab it and pull it out, that blade goes right in your hand and you get shocked. So some of them can be bladed. Now, when you're replacing fuses, always make sure to have, always have the label facing out. I've had state inspectors write me up because the label wasn't facing out. And these two fuses, real quick, look the same. But when you zoom in, you'll see the bottom has got a little ridge on it. This one don't have a ridge. So you stick this one in there not knowing that little ridge, and it doesn't make proper electrical contact. So these are just some of the hazards that I ran into. So anytime you pull a fuse, set it aside and leave it there. Now, a guy at our company thought he was a hot shot. I don't know if you guys know what a Leatherman is. This is a Leatherman
Yeah.
tool. These Leatherman tools have killed more people than anything. They're in a big hurry. They're not insulated. They forget that the power's, they don't know if it's on or off, and you get shocked. Don't ever use our company. If you get caught with one of these, you're fired. So make sure you want to get insulated tools, and you want to make sure, see how there's a little thing my hand can't slide up. So when I go on the disconnect, see those guards? That my hand can't accidentally slide into the power. See those guards right there? These are the kind of tools, Klein tools that you want to get. So I could keep going, but one more quick thing. For you people with older houses, you get these glass fuses, you really can't see when that thing pops. So you see how that one's got brass? They look the same, but they're not. They're actually a different diameter. It's plastic and it's actually smaller. But I've run into all these problems. If I could save somebody's life by telling you pull the disconnect with your left hand, it was worth it. There's my electrical safety practice presentation. Any questions?
Thank you for doing it. One thing I would just add, not being an expert by a long shot,
No, I understand.
Thank you.
always wear safety glasses.
Right. Always wear. However, when you wear glasses, a guy at our company, true story, he had wire rim safety glasses, stuck his head in the controller, electricity went around and blew out the top of his head. He was safe. And that guy couldn't, once that happened, his memory improved 1,000%. I did it myself. Everyone said if you show them a chapter in a book, come back a year later and ask them what chapter you showed, it worked. I swear it worked. I'm telling you. That electricity going through his brain improved his memory 1,000%. The guy could read a print and tell you exactly where every contact and point was. You wouldn't believe it. So anyway, thank you.
Are you telling me if I stick my fingers into a socket, I might improve my memory a little bit?
Yeah, I'm not telling you that legally. I'm telling you what happened to him. But it looks like you got wire rim glasses. So don't get too close to that energized system because it could jump out. You want to make sure that you got plastic glasses on. And don't wear belt buckles. They issued us all these dumb belts that are non-insulated that don't work. If you got caught with a metal belt buckle on and you're working in a controller, you're fired. So make sure never carry keys. All right, I'll stop.
Marv, he might have I had the same idea too, but my luck it would travel a different path than his did.
No, this guy really got shocked. It blew out the top of his head with where his memory, he couldn't forget anything. You could ask him a question and a year come back. I tested him over and over again. He passed every time.
Well, I appreciate you sharing your wisdom, Ralph. Thank you.
Yeah.
Well, that's all. So I worked for United Technologies for 38 years doing motors and generators. And if I made a mistake, I died. So it's called habit. You get in a safe work practice and you always pull the disconnect with your left hand. You always test and verify. You just do this religiously, the same thing over and over again, and you'll live to tell about it. So when you get in a hurry and you start cutting corners, that's when you run into trouble.
Talking about all this safety made me think of the guy that got hit by lightning more than once. I don't think he has too many friends.
Yeah. No, believe it or not, most people that get hit by lightning are improved. Guys get their sight back, their hearing back. That lightning, I think, is a good thing myself.
If you survive.
Right, correct. You don't want to be near a tree either.
And by the way, Ralph, I treated a guy in my profession of physical therapy who did work on electrical lines, and a line went through him and out his foot. I had to treat him for his foot.
Mm-hmm. And like I said, I had a guy at work. He thought he was going to be a hot shot and work on the lighting in the garage. and it was DC. It was a really high voltage DC power. It wasn't AC. He thought it was AC. He started working on it. He grabbed the wire, wasn't disconnected, and it closed his fist on it. When you get shocked with DC, your muscles all contract.
Yep.
And you cannot let go of the wire. It's humanly impossible to let go of the wire. So when you work on DC power, be real, real careful. AC, it's impossible to hold on.